live. Here we go. Good. Okay, so today, what are we talking about? So today we're talking about our rational functions, okay? So the word rational is a math word meaning fraction. Remember that. That's on the SAT. They will ask that question. They'll say, which of these are rational numbers? Any number that can be a fraction is rational. Any number. 3, 1/2, 0.2, right? 0.3333. That can be a fraction, right? Numbers that are not are called irrational. Pi is irrational. The square root of 2 is irrational. The square root of 5 is irrational. The cube root of 100 is irrational. But any number that can be a fraction. So those numbers that go on forever, that never stop, are irrational. Like your boyfriend or girlfriend, they're irrational, okay? They go on forever and never quit. I said boyfriend and girlfriend, didn't I? Okay. So, if we graph this on our calculator, it looks like that. You guys get it? And what's going on is that it becomes irrational here. It's going off to infinity, isn't it? So as we get closer and closer divided by 0, it goes off to infinity. As we get divided closer and closer to 0 on the negative side, it goes down to negative infinity, okay? So what we get are these things called asymptotes, okay? And asymptotes are boundary lines. We've seen asymptotes before. So I put an asymptote here, and I know that my graph looks something like this. And we get an asymptote here. And we get an asymptote here, okay? So we've got two sets of asymptotes. I have horizontal and vertical asymptotes. So I have a horizontal asymptote at y equals 0, okay? Because if you can't divide by 0, you can't get an answer of 0, because the y value is your answer. So you can't divide by 0, nor can you get an answer of 0. And you've got a vertical asymptote. And your vertical asymptote is at x equals 0. Because x can't be equal to 0, that's why you have an asymptote. We know that, right? Cannot do it. Okay, so range and domain. Well, range and domain is pretty easy. It's forever wide. Domain, it's forever wide except for one spot. Right? It's forever wide except for one spot. What can't it be? What can't it be? 0, right? So my domain is everything. It really is everything except at 0. So my domain is going to be x equals all real numbers except x cannot equal 0, because if it equals 0, we're going to divide by 0. We're going to make Cookie Monster unhappy. No cookies for you. Sad, sad, sad day. The range, reach for your range. The y values goes forever up and goes forever down except for one spot, right? And that's at 0, okay? So if I have the range, it's simply y equals all real numbers except y cannot equal 0. So, listening, 0 on the top is 0. It's the number 0. 0 divided by 10 is 0. Cookie Monster would say if you have 10 friends and 0 cookies, you can do that. Everybody gets 0 cookies, right? 0 divided by 2 is 0. If you have 2 friends and 0 cookies, everybody gets 0 cookies. You can do that, right? But you can't say you have 2 cookies and no friends, because how do you divide up 2 cookies under no friends? You just can't do it, right? So 0 on the top is 0. Say it. 0 on the top is what? 0. Okay, good. 0 on the bottom is? 0. Bad news, right? Right? Bad news. 0 on the top is? 0 on the top is 0. 0 on the bottom is? Bad news. Okay, good. Remember that, okay? So now, example 2, it's the same graph except we're going to move it. We're going to do a shift. We're going to do a shift. What we're going to do is move it to the left 2, because we're going to go the opposite. Remember that? We're going to go the opposite. And then we're going to go up 3. Now, what we're going to do is take the asymptotes and move the asymptotes. Does that make sense? So I'm going to take the whole graph, I'll move it back 3, so I'll go back 2, I'll go 1, 2, and I'll move it up 1, 2, 3. So my asymptotes then are here. Here's my vertical asymptote, and here's my horizontal asymptote. And so my vertical asymptote is at x equals -2, and my horizontal asymptote is at y equals 3. Now let's put it in the calculator and take a look at it, okay? So I might shift my window up a little bit. I might just take my window and take it up a little bit higher. I might go maybe -2 to say, oh, go to it. Hold on. Go back to window. Go my -2 to, I'm going to go 8. Y equals clear, and I'll put this one in. I'll go 3 plus window. Sorry, yeah, I'm just changing. In fact, I can change my left one too. Maybe I might even change that one to -8 to +2. I'm just moving everything over. That's all I'm doing, is moving everything over in my window, okay? And you don't have to do this. I just kind of know we're moving it over anyway. So why not move my window over? All I'm doing, Zoe, is move my window over and up. Okay, that's all I'm doing. Okay, so then y equals 3 plus my 1 divided by parentheses. Gotta have parentheses because you need the x plus 2 on the bottom. Parentheses. Gotta have parentheses. X plus 2, and then I'm going to graph it. Okay. Now my calculator shows an asymptote, but it's not really there. This line is not really there. You guys agree? It's invisible. Some calculators show it and some calculators won't. Anybody have it? You're going to graph it and there isn't an asymptote there? Good. Can I see graph? Okay. Because here's the way it should be. Thank you, Zoe. Zoe's got the good calculator. So obviously the asymptote is not part of the graph. Here it is. There's a better picture of it. Hold on, Zoe. Let's see if I get it. Can you guys see Zoe's yet? Kinda. Okay. Zoe's, it shouldn't. The asymptote is not part of the equation, right? Okay, nice job, Zoe. Okay.
Do we have the same one image?
Yeah.
No way.
Oh yeah, those are nice calculators. Okay.
Really?
Love it. So it, same exact graph. It's going to look like this and like this, okay? Now if this is negative, the whole graph is just upside down. I'll say it again. I don't have one. But if this were a -1 here, then the whole graph's upside down. Does that make sense? If this is a negative here, the whole graph's upside down. Right? Okay. All right, number 3, describe the transformation from fx equals 1 over x. Vertical and horizontal asymptotes, so what is the end behavior, okay? So the translation here, we already said, translation was we went back, we went to the left 2, and we went up 3. And my asymptotes, well, that's easy. My asymptotes, my vertical asymptote is at x equals -2. And we can see that. There's x equals -2. It's right there. And my horizontal asymptote is at 3, right? My horizontal asymptote is at y equals 3, all right? I'm going to shift back down and talk about something you know. Everybody got that? Am I going too fast? I can probably leave it right there. It's okay if you can probably leave it there. Okay, so let's go back to the original equation. If x were -2. Okay, think about it. If x were -2, just come on, use your brains. If x is -2, you watching? What's -2 plus 2?
0.
Don't divide by 0, right? If x were -2, -2 plus 2 is 0. Don't divide by 0. That's why the vertical asymptote is at -2. Okay, does that make sense? Okay, you ready to turn the page? All right. Now, this one, I know where the vertical asymptote is right off the bat. Before I do anything, before I do any fancy math, here's what I know. X cannot be -2. Cannot be -2. Why? Why?
0.
Right? But now, what I'm not sure is where the horizontal asymptote is. So let me flip the page real quick so you can see it. So from this form right here, I got my horizontal asymptote because it was 3 plus, right? So what I want to do on example 3 is use division. I can use long division, which is really easy on this case, or we can even use synthetic. Do you want to use synthetic division? Okay. So synthetic division, we'll go -2 into my 3 and my 5, and then my remainder, right? So I can slide down my 3, and I'll get a 3. 3 times -2 is a -6, and I'll get a -1. Okay? So my answer is 1 less power. So it's not going to be a 3x, it's just going to be a 3. So my answer, y is also equal to a 3, right? Plus a -1 over an x plus 2. Okay, these two are the exact same equation, just a different form. So I got my 3, right? I got my 3, and then plus my -1 over what I divided by. So, okay, one more time. This is a regular 3 because it's 1 less power, right? 1 less power. So it's 3 plus my -1 over x plus 2. So now, that's where my horizontal asymptote is, right? That's where my vertical asymptote is, so I can put this in. So, okay, I'm going to go to my 1, 2, 3. My vertical asymptote is at -2, and my horizontal asymptote is at 3. See how I'm getting this? So it's nearly the same graph, except it's upside down. So it's nearly the same graph we just did, except for this one is going to be a reflection. It's going to be a reflection over its asymptote. So it's going to look like this and like this. And again, we can graph it. We can always put it on the calculator to double check, right? If we're not sure what's going on, we can always say, okay, I want to graph this. So I'm going to go to y equals clear, and I can put the original parentheses 3x plus 5 divided by parentheses x plus 2. Let's use the technology, right, Ben? This was for it, right? I mean, I think it's crazy that some math teachers don't let you use it because everybody else uses technology, right? Graph sure looks exactly like what I just put down, right? And again, the vertical asymptote shouldn't be here, but my calculator graphed it. It shouldn't be.
Why?
It has to do with the size of the pixels. I mean, the calculator's trying to find it. The calculator doesn't do math. It just finds it. In a sense, it instantaneously plots points. So, okay. So, find the x and y intercepts. So, what about the x and y intercepts, okay? First of all, the y-intercept is easy. What about the y-intercept? What do we know about a y-intercept? Well, think about it. The y-intercept, I got it right about here. I don't know if that's exact, but what is the height of a y-intercept?
0.
Good. So if we let the x equal 0, we'll get the, if we let the y equal 0, we'll get the x-intercepts. What do we know about the y-intercept? What's the x value? What's the x value of the y-intercept?
0.
0. So let's find the y-intercept by letting x equal 0. Does that make sense? So just let x equal 0. So y-intercept, we're going to let x equals 0. So I'll go back to my original. Y equals 3x plus 5 over an x plus 2. But if I plug in 0, right? If I plug in 0 for x, put a 0 there, and put a 0 there, I'm going to get 5 halves, or 2.5, right? So my y-intercept is at the point 0, comma 2.5, all right? And I am way off, aren't I? I'm way off. I've got it here. It should be there, correct? Sloppy. Sloppy. So it really should look more like this, shouldn't it? How about the x-intercept? So if I want to find the x-intercept,
Can you push it up a little bit?
I sure can, Celeste. If I want to find an x-intercept, How am I doing?
Okay, so that's
Oh, sorry, Sydney. Let's let the y equal 0, okay? Does that make sense? So, I'm going to have 0 equals 3x plus 5 over x plus 2, okay? Zero on the top, 0. I'll say it again, 0 on the top, 0. So we don't even care about the bottom. Okay, you ready? 0 on the top becomes 0. So what x value would make the top or the numerator? What x value? So all you have to do is set this equal to 0. Don't worry about this. In fact, if you want to, you can multiply up. That it disappears anyway. So you could multiply this up, it disappears anyway. But if you want to find out what makes it 0, it's only the numerator. So I'm going to rewrite it and only worry about the numerator. So let's rewrite this as 0 equals 3x plus 5. And we'll solve, okay? Because if the top numerator, if the numerator is 0, the whole fraction is 0. 0 on the top is 0, right? Okay, so solve minus 5, divide by 3. So if x is negative 5/3, again, I'm off a little bit on.
I did not follow this.
Okay, I know, it's early. You guys might mind. So minus 5, and then divided by 3. You with me? I just did minus 5, and then I got 3x to divide by 3. Okay, got it. So again, I'm off by a little bit, so it should probably have been right about here. So I should have put my graph right like this. There's my x-intercept, there's my y-intercept, and now I've got it graphed a little bit better. Sloppy, huh? Okay. All right. Last but not least, here is a concept in calculus you have to know, but it's really easy. First of all, let me graph it. Before I do anything, let me graph it. Clear. I just want you to see this. To me, this is kind of a cool thing. You're going to like this. Y equals clear. I'm going to go parentheses. X squared plus 2x subtract 3. X squared subtract 1x subtract 12. Might have to change my window slightly. Yeah, I'm going to have to change my window, but that's okay. My window, let's go negative 10 to 10. And we'll go negative 5 to probably 5 should do it. Let's graph it. There we go. Okay, there it is, right? So I've got an asymptote. Do you guys see the asymptote? Where's the asymptote at? It looks like it's at about 1, 2, 3, maybe 4, right? Okay, so let's factor. I've got an x plus 3x minus 1, right? Okay, what times what makes negative 3 that also adds up to 2? We've got a positive 3, negative 1. Capiche? I know it's Monday morning, I know you guys are tired, but you're good on that? I just factored. Multiples of negative 3 that also make positive 2, plus 3, negative 1. Okay, let's factor the denominator. Okay, so factor the denominator. How about an x minus 4 with an x plus 3, okay? Okay, you kind of awake?
no.
Okay, semi-awake? Okay, you ready? Big idea, big concept. Big concept. X cannot equal 4. Agree? Okay, let's write that down. X cannot equal 4. So, x cannot equal 4. Okay, in fact, let me go back to my calculator graph. I just graphed it, right? Okay, what happened at 4? What do you see? Come on, put the two together.
It doesn't land on 4.
Right. Can't be 4. You guys agree?
Yeah.
You have an asymptote of 4. Okay, one more time. Let's put the two together. What value of x? What value of x causes me to divide by 0? 4. So I should have an asymptote at 4. What else can x not equal?
Negative 3.
X cannot equal negative 3. But there's no asymptote at negative 3. But there's a hole. There's a hole at negative 3. There's a hole. There's a hole. In fact, right here, there's a hole. There's a hole right there. I don't see a hole. It is microscopic. How wide, how thick is a point? How thick is a point? How thick is a point? Okay, so I'm saying x cannot equal negative 3, right? But can it equal negative 2.99999? Can it equal negative 3.00001?
No. Yes.
Sure. So as you're getting closer and closer to negative 3, there are points there. There are values. But when you get to negative 3, hey, check this out. Hold on. Trace. Negative 3. Boom. Huh? Does that bother anybody?
Maybe.
Or do you notice what I notice?
There is no.
There's no y value. There's no y value at negative 3. There's just none because there's a hole there.
Why didn't it get to me?
Right? So I just, actually, Zoe, here, do this. Push your trace button. Push trace. Zoe, listen.
I pressed straight.
Trace trace and then type in negative 3 and enter. Enter. Goes right to it, doesn't it? Okay? So, if there's no y value, there can't be a point there, right? Now, I don't even see a hole in there, but again, you're right, Zoe. The hole is actually this wide. You with me? It's this wide, but it exists, okay? So, there's a hole at negative 3. So, I want to write that down. Let's take a look at what's going on. So, there's a hole. There's a hole at x equals negative 3. Okay, now, listen to this. Removable. Removable. So, Cookie Monster says you can't divide by 0, right? That's the problem. If Cookie Monster doesn't like it, it's got to be bad, okay? So if I take a look at this problem, what do you see? Come on, everybody sees it. Take a look at this. What do you see? Well, come on, what do you see? They cancel out. What cancels out? Yeah, so the problem is removable. So if you can't remove the problem, it's a hole. Does that make sense? Because I can cancel. It makes a totally different equation, but if you can cancel out or remove the problem, it's a hole. But if you can't get rid of it, it's an asymptote. I'll say it again. So if it's removable, it's a hole. If it's non-removable, okay? If it's non-removable, it's going to be a vertical asymptote. The x minus 4 I can't get rid of. I mean, it doesn't cancel. You guys agree? You're stuck with it. It's non-removable. It's an asymptote. The x plus 3 cancels out. You can get rid of it. You can get rid of the problem. It's a hole. Okay? Thing is that this is not my original equation, so we have to be careful on this. If I do cancel, I get an x minus 1 over an x minus 4, right? If I do remove it, these are different equations. They really are different equations. Now, where's the hole at? Well, the hole is sitting at, go back to my calculator. I'm almost done. I'm not kidding. So let me go back. So my hole is sitting right about there, right? You guys see it? Oh, you can't see it. So my hole is, let's see, right about there. You guys see it? It's at a point. It's an invisible point. It's a hole, but it has a position, doesn't it? So it has a y value. So here's how you get the y value. You plug it into after you simplify it. So let me show you that. Okay. So after I remove my problem, let me just casually remove my problem. It's gone, and then it becomes y equals x minus 1 over x minus 4, right? I just cancel. You with me? And it changes to this. Okay? Cancel, it changes to this. Now, can I plug in negative 3? Sure. Can I plug in negative 3? Sure, I can plug in negative 3, can't I? So if you plug in negative 3 now, you'll get its corresponding y value. So if I plug in negative 3 for x, now I can. Once you remove the problem, then plug in x equals negative 3. So all I'll get is a negative 3 minus 1 over negative 3 minus 4. Oh, what's that? A 4 over negative 7 or a 4/7. Okay? So I can plug it in, right? I got rid of the problem. Boom, it's gone. Now I can plug in negative 3 without a problem. I plug it in and I get 4/7. That's the other part of the hole. So my hole is at, here's my hole sit. My hole is sitting at negative 3 comma 4/7. All right, so my graph should look like this. Okay, I got it on my calculator. That's nice. But I do know quite a few things. My it has a whole 1, 2, 3, right? It has a hole right about there. It has an x-intercept of 1/4. How do I know it's 1/4? It has a, y-intercept of 1/4. Do you see the 1/4? Do you see the 1/4? Do you see 1/4? If all the x's are 0, what are you left with? Do you see the 1/4? Do you see 1/4?
Can you say one more time?
If x's are, if all the x's are 0, what am I left with?
1/4.
Guys see 1/4? So if my x's are 0, my y is 1/4, which is right about there, okay? Okay, so I got a point right about there. I've got an asymptote at 4. 1, 2, 3, 4. So I've got a vertical asymptote at 4, right? I know that because we already said it was a vertical asymptote because x can't equal 4, right? Now there's one more thing, and that is it's super easy, the y-intercept. I'm sorry,
No.
x-intercept, right?
2.5. No.
0 on the top, 0. 0 on the top, what would make this 0? 1. So if x were 1, then y would be 0. Now, you'd say -3, but that's a whole, isn't it, right? So at positive 1, so it's going to go through here, and my graph, my calc, it's going to look like this. You ready? Can you see it? It's going to look like this. My graph is going to go boom, across. It goes shooting down and shooting up like that. Now, where is my horizontal asymptote? It's at 1. And we're going to talk about that not today. We'll talk about that later. Okay, so looks like that. That's a really bad graph. It's a terrible graph. Was that too much for a Monday after homecoming weekend?
Yeah.
Oh, that's all right. We'll just do